The final lesson for using 3D sketches with splines will use the helmet example that we went through earlier. In this case, let's use the filter to find all 3D sketches. So I'll just type in 3D in the filter. This helps me identify 3D sketch number 2, which you'll remember we used to convert entities on the projected curves. 3D sketch number 3, which was a small detail that helped us close up some of the surfaces that weren't properly dealt with the mirror. 3D sketch number 4, which we used to help us create the face mask. So let's go through each of these cases and see how and why 3D sketches were used in these cases. The first use of the 3D sketch, you'll remember, was on the ridges on the helmet. In this case, the 3D sketches were used to overcome limitations in the projected curve functionality. If we use the filter to look for curves, we see that the projected curves show up directly underneath the two splines. These was used to convert the curves into 3D sketches. There is no 3D sketch technique that's equivalent to the ability to project a sketch onto a face. So this is a technique that is considered a workaround, but the bug that it works around has been in SOLIDWORKS for a long time. And sometimes you just need to get the job done. The second case in which 3D sketches were used in this model was the air scoops on the side. In this case, if we roll back the model, the edge of the scoop does not match the edge of the trim. When we created the scoops at the jaw, you'll remember we created planes. But in this case, no plane was created. The 3D sketch was simply sketched from point to point with one internal point, and then the handle was used to create the shape. Let's take a look at how this was done. Start with a spline, cursor over the corner, click, click, and double click. Notice that both endpoints are black. If you select the spline, Control select the edge, and then Control select again the face, you can get a tangent to face constraint. Let's do this on both sides. Click the spline, Control click the edge, and then Control click again the face, and the spline will be tangent to the face. To get the shape on the inside of the spline, I click the middle point and hold down the Alt button and the handles. Holding down the Alt button edits the handles symmetrically, so this is only used on internal spline handles. Drag the handle out until it gives you a nice shape at the ends of the scoop. As always with a 3D sketch, you need to be careful to look at this from multiple angles. This may not be giving you what you need from all points of view. So in this case, you may want to adjust the direction of the spline handles. And you may have to do this multiple times to get it just right. The third instance of the 3D sketch in this model, we search again, is found at the top of the model. In this case, we'll roll back again and roll back once more. Trick of rolling back between the feature and the sketch. And what we had to do in this case was we had to fill in this gap. In order to fill in this gap, there are a couple of methods you could use. You could use a boundary feature But remember, a boundary feature is not going to do well with really pointy geometry like what we have here. So the next best bet is the filled surface. But in order to use a filled surface, we have to have, ironically, a boundary that goes all the way around the gap that we want to fill. So the best way to do this is to create a line. You're not sure that any of this is planar? It really works best in 3D. So let's create the 3D spline. Again, we'll just do a 2-point spline, assigning end conditions of C2 or tangency. In this case, the C2 does not work very well. So let's undo that and just apply tangent constraint. With this surface being so small, it probably doesn't matter whether it's C2 or tangent. So with this 3D spline in place, we've now got a closed loop around the gap, and if we exit the sketch, we can use a fill surface to select our faces. After the first select, I'm going to set it to tangent. Sketch selections in the patch boundary can only have a contact condition. If we wanted to do something else, we should have extruded this and created this part of the boundary as an edge of a reference surface. But in this case, it doesn't matter. And this should also be tangent. And then select the remaining two. Close that boundary. SOLIDWORKS creates the face. Thankfully, the surface that it creates is symmetric, and SOLIDWORKS will trim it automatically. If we ask it to merge result, it will also knit it into the rest of the model. And the result looks pretty good. All right. It's very small, but it was an important detail. And the final feature that used a 3D spline in this model was the face shield. The face shield looks more complicated than it is. First thing we look at when we see it is that it's symmetrical. So let's roll it back and take a look at how this was created. The first step in making this was to realize it was symmetrical and to create a reference surface from a sketch that was extruded to create an edge out here in the middle. This is because the fill surface on larger areas cannot be trusted to be symmetrical, even if your inputs are symmetrical. So it's the best practice to just make half of whatever you're with the fill surface. I remarked on this in the last feature because the fill surface frequently produces geometry that is not symmetrical. In any case, we've created this edge right on the mirror plane, and we're going to use this to create the face shield. But in part of doing this, I also need to create a 3D sketch to give me some shape for the face shield. Now, looking at this, the 3D sketch is not symmetrical either. Just as long as we have one side of the face shield symmetrical, and the finished product should be good. I used a 3D sketch in this case simply because it was a lot easier than doing anything else. Many people think of 3D sketches as being difficult, but I could have created a plane that went through the same 3 points. So first created a plane and then created a sketch. That would have been one way to do it, but just to create a 3D sketch is an easier way to do it. If you've already got a point over here, so we'll just select on a point. We'll put the midpoint here on the midpoint of the edge, and then go over and just place this point on the other side. Make sure that it picks up the edge, and that's all you really need. Escape to finish. Click on the 2 endpoints and give them an along X relationship with one another. Now, where you're going to find some difficulty here is going to be using the handles. If we use the handles are not necessarily symmetrical from one side to the other. So one way to get around that is to handle for the center to use the along X relation. Doesn't really matter what's happening on the other side. Just as long as this side is good, this is the only side that matters. From here, create the filled surface using this edge from the helmet, this edge from the reference surface, and as a constraint curve, use the 3D spline. Make sure to set the condition on the reference surface to be tangent. This is what the mirror feature work. Once this surface is mirrored, then everything looks fine.